Hi everyone, I'm David Gothberg, as you said, or David Göthberg in German. I'm from Sweden, but I speak German too, so afterwards you can ask me questions outside in English or German or even in Scandinavian languages if you like to. I'm going to talk about something I call subnetting in peer-to-peer systems, but I realize some people have a problem with that name, so you could call it subgrouping in peer-to-peer networks if you prefer. I'm a researcher full-time on peer-to-peer systems. I started researching in 1997, and since 4 years back I do it full-time. So this is what I do for a living right now, so to speak. First of all, what peer-to-peer systems are, because people always misunderstand what I mean with peer-to-peer systems. One thing all know is file sharing. Everyone has seen file sharing. There's lots more to it. You can do distributed chat systems. You can actually do a distributed IRC server that has actually no servers. You can do distributed telephony systems, totally serverless, where the clients can call each other and talk on the internet, or instant messaging, or distributed internet radio and TV and so on. That is no. So what I'm researching is fully distributed systems, totally serverless. No one is boss, everyone is equal in my networks. So, well, the reason I use subnetting is that not using subnetting to be monolithic like most systems are today is very inefficient. For instance, most people here have used IRC, I think. How many here do not know what I mean by IRC? Please, okay, good. In most monolithic peer-to-peer networks, you have a big network, and everything that goes on inside this big network. So that means that if node A wants to speak with node B, they have to route messages over the entire network, loading all the nodes in between and using their bandwidth. And that's pretty stupid, I think. So if we think of IRC, we're a node in this big mother net, I call it, and we want to join a channel or chat room, that is. So I make a chat room, and when I join that chat room, if I have the first node, I actually make a subnet. That is, I create another little peer-to-peer network underneath this mother net. And I announce this other net, this subnet on the mother net. And other nodes that want to join this channel, they simply join this subnet. So all nodes that's in this chat room are their own little peer-to-peer network. That means they are directly connected to each other, or at least some of the neighbors in this room. And any messages inside the chat room are broadcasted within this subnet and never traverses the big mother net. So only nodes involved in that chat room actually gets the load of the messages, and they want that load because they want to see the messages. So that makes it very efficient. But there are plenty of more reasons to have subnetting. This was, well, like the easy example. Another one is, for instance, internet telephony. Say your wife is on vacation in Thailand, and you're on vacation in America, and you log into two different computers and you don't know where the other computer are, you don't know their IP number or anything. So you install this little telephony software, and it logs into the mother net, and you have usernames. Say I'm David and my wife is Vlada. So we type in our usernames and create little subnets. So my subnet is the subnet named David, and my wife's subnet is Vlada. So when I want to talk with my wife, Vlada, over the internet, my node, I type in I want to call Vlada, so my node joins the subnet Vlada, and suddenly she and I are in the same subnet and find each other and can start talking with each other. So that's kind of a weird example, because that subnet is really only her node. So it's
1 minute left.
Okay, sorry?
1 minute left.
Oh, really? But the really neat thing is future compatibility. That is, if I have a file sharing network, for instance, I have search algorithms running on this, algorithms making me able to search the network for files. However, this is an evolving science, how to search. So what I do is I create a subnet, and I run the search algorithm in the subnet. That means the next version of the software, when I have a better search algorithm, can make another subnet and run another search algorithm in another subnet without disturbing the old nodes. And when I get even more in the future, I can plug in more and more search algorithms and stop supporting the old ones by nodes just joining the subnets where where they have the algorithm and can support that kind of search algorithms. So it can be future compatible in that way. And that makes it very flexible.
Sorry, your time is up.
Yeah,
So.
okay. I'll be available outside for questions afterwards.